the simulation involves 40 T numbers, 30 T numbers that is taken from the database with decimals, several digits, decimals. So I think 31 digits. So that's the zeta function, the zeta zeros, and then 10 that I've chosen, that is in between the zeta zeros number. So this list is the same list used from prior simulations. Also the sigma is also the same list, but now in the dashboard, generate text dashboard, I'm also using 4 different terms. So we're calculating it in n equals 1,000, 10,000, and 100,000 and 1 million. And in just that dashboard, you do see that there's changes occurring depending on the terms that was used. Sometimes the sigma values to the left that are negative, that are heading towards negative sigma. Sometimes it's the lowest, sometimes it's the highest. So we do see extremes on the left or even the right, the one heading towards 4, sigma number 4, or getting more positive or higher positive values. But what is consistent is that around the critical line, 0.50, 0.49, 0.48, these are more balanced. Like I could see it, like just, it was always around 15, 14, 18, maybe 20, but certainly the average is 15 or 16. And so around that area, but the rest are so sensitive, you can easily see the changes. But yeah, so in that dashboard you can see the output changes. It either decrease or increase. It may change signs, so depending on the terms. And in fact, I think about 10,000 would probably be okay. I mean, it does change, the output does change dramatically depending on the terms. So like sometimes it's less than 1 starting in the term n equals 1,000, and then if you change it to 1 million, suddenly it's like 11, negative 11 or 11, or like 2 digit after the decimals. So I guess it depends on your analysis to that. You might think maybe n equals 10,000 is probably more balanced, because you would need, if over that, you would need more and more terms to cancel out, because at first it would really increase the absolute value of the output, and then perhaps 1 million is not enough, and then maybe you need more. But that UDF that ChatGPT gave to me, it can still handle 1 million terms, but there is a noticeable lag. But 10,000 is fine, even 100,000 is fine, but not 1 million. 1 million, it starts to delay, to create some delay, but not. Probably I wouldn't. It will totally freeze, like if you enter 100 million. I've tried 10 million, and it is normally like, it's heavy in calculation by that time, so I didn't even try the 10 million terms. So yeah, so eventually the visualization is showing, that diagonal, those extremes, that as you increase the sigma to the left and to the right, it's, the range increases and it forms these diagonals, and then you see the convergence into a single point, which is at the critical line or around that critical line. But you do see it shifting. The center would shift a bit to either left or right, depending on the terms and depending on the other choices that you have. So that second visualization that it retrieves, it actually just counts the using the file names in those folders, and it counts, and then it return a count if it is greater than 0. You know, if there is a count, then it returns that. So that's why we generated those, or I generated those texts with those file names for easy counting. But there are many combinations to that visualization. You can have you can have different terms, different t type, non-zeta or zeta or O, or cosine or sine. So there are many combinations, and then you can just hit the button to visualize it. So